Okay, we're back. So we were adding and subtracting complex numbers. Maybe I'll do just one more. 3 minus I plus 5 plus 2I. The real parts get dealt with similarly, and we look and see what operation is here to tell us what to do. So this is 3 plus 5. And then plus, we have minus 1 plus 2. This is minus 1 plus 2. And then we factor out the I. So this is 8 plus 1I, which we'll write as 8 plus I. And that's it. Once again, more on this graphing. This point here, this is 0 plus I, but we would just call it I. This is negative 1. This is negative I. This is 1. Some interesting things happen here when you multiply by I, and I'd like to point out to you. I'll draw a bigger picture so you can see. So we determined earlier that I cannot be a positive. I cannot be thought of as positive and negative in our usual terms, because I squared is negative 1, and when you multiply two positive numbers, you get a positive number. And when you multiply two negative numbers together, you get a positive number. So it's not positive or negative. And that's interesting. However, there is a real number that's also not positive or negative. Can you think of what it is? It's 0, right? Is 0 positive? Well, is 0 positive? How could you tell if a number is positive? When you multiply a positive number by a negative number, what happens? This is a little diversion here. I just got on this. Suppose this is positive. Well, when we multiply negative 1 times 1, this is negative 1. If you multiply a positive number by a negative number, you get a negative number. So if this is positive, then negative 1 times 0 has to be negative. But negative 1 times 0 is 0, and we said it was positive. Or I suppose you could say negative 0, but negative 0 is the same thing as 0, right? So it's not positive. Well, suppose it's negative. Suppose negative 0 is negative. Well, if it's negative, when you multiply two negative numbers together, what happens? Well, negative 1 times 0 is 0. If you multiply two negative numbers together, you're supposed to get a positive number. But this is negative because we decided it was negative to start with. So what I wanted to, the reason why I brought this up is, number one, 0 is a neat number. It has a lot of cool stuff going on. But 0 is not positive or negative. Real number. So I wanted to show you that there are, in the complex field now, we have something else that is not positive or negative, but I wanted you to get the feeling that this isn't that unnatural. Because we already know in real numbers, 0 isn't positive and negative. So what else? So what was this about? I, which is the square root of negative 1, we figured out is not positive or negative. In the sense that we think of positive and negative numbers for behavior for real numbers. So let's look at, I'm going to blow this picture up really big. So this is the point 1 plus 0i. We typically don't write the 0i. This is 0 plus I. Here's 0 plus 2i. So this, in theory, should be written as 0 plus I. We just don't put the 0 in front. It's a matter of convention. I really think that you should, to make sure you understand. This is, so if we write 1, we should write 1 plus 0i. The reason is because 1 plus 0i is a complex number. 1, without the proper context, is a real number. It's the one you know is real. I am a somewhat retentive mathematician, and I think that these distinctions should always be apparent and clear. I'm the vast minority on that. What happens if you multiply a number by I? So what is I times 1 plus 0I? And I'm just saying that this is complex. So this is going to be I plus 0 times I squared. This is, of course, just I, which in theory you would write as 0 plus I. I'm going to stop doing that. But so if we start here and multiply by I, we move here. So this is what happened. And I want to show you something amazing. What happens when you multiply real numbers together? Basically, you stretch down the line, right? Suppose we do, if we start 1, 2, 3, 4, 5, 6. If we start, here's 1, 2, here's 3. If we multiply 2 times 3, we end up at 6. Basically, we stretched out, right? Or what really happened was we laid a stick that's 2 units long, 3 across, right? So 1, 2, 3, 4, 5, 6. We went that way. So now let's multiply by I. We multiplied 1 by I, and we go to I. I times I is I squared. This is negative 1. So if we multiply again by I, it comes here. If we multiply again by I times I, which is negative 1 times I squared, or times I, because I squared is negative 1. This is negative I, which is, of course, I cubed. And here is negative I. What I want you to see, we'll do it one more time. We multiply it by I again. This is I to the 4th. This is 1, we know. Hopefully we know, because I squared is negative 1. Negative 1 times negative 1 would be I to the 4th, and this is 1. So multiplying by I, I'm having trouble today, by I is rotation by 90 degrees in the complex plane. So that's pretty neat. Instead of when we multiply real numbers together, basically we're laying out sticks and we're going this way or this way down the number line. We're increasing our length going that way, assuming that it's bigger than a fraction or bigger than 1. But when we're multiplying by I, we are seeing rotations in the plane. And there's really complex numbers, and the behavior of complex numbers has been so significant. Understanding the behaviors of complex numbers and modeling physics have just grown up hand in hand. And there are so many significant discoveries that each has brought to each other. Complex numbers are not a real thing. They're made up like real numbers, but they're like a language, and we can describe things in physics in that language. And also some of the things that we've described in physics, we've come to see in the complex number field. So not only has math generated some interesting ideas, but physics itself has generated some interesting ideas for the math. So we'll be back.